Welcome back. In this session, we will discuss about the passive loading scheme, which is the solution of problem that we have discussed. The passive loading scheme is published in IEEE paper of 2011. The novel simulation approach to analyze the performance of switch electrons motor drive with in-wheel vehicle. So in this paper, they used the switch electrons motor and validated the passive loading scheme. So we will see when the two separate models are available, how passive loadings can be used. The passive loading says the first thing we need to do is to derive the torque speed characteristics and store it in lookup table. We already derived it and we know how to store it in lookup table. So we are having the vehicle model. From the vehicle model we have derived the torque speed characteristic and stored in lookup table. So now in this lookup table our input is speed and output is torque, but unit is important. If we have stored the lookup table with the input in the speed, unit is kilometer per hour, right? So what passive loading scheme says? It says that consider the vehicle, either two-wheeler or four-wheeler, as a solid cylinder with having mass is equal to total weight or mass of the vehicle. This is the first thing that we need about the passive loading scheme. So it considers the vehicle as a cylinder with having the mass is equal to the mass of the vehicle, and the radius is equal to radius of the wheel. So the radius of the cylinder is radius of the wheel. So now the vehicle is solid cylinder having the mass and having the radius of the wheel. So when this mass is moving and this radius with the radius of the tire, so we need to consider this, and inertia of this cylinder is mr square. So this inertia of cylinder will be considered as inertia of rotor. So now our rotor of the motor is not having only weight of the rotor, but consider the cylinder having total weight of the vehicle, and the inertia of solid cylinder can be found mr square. So this inertia will be much higher than the inertia of the rotor. So it is 0.0215 is the inertia of rotor kg meter. So we can change the inertia, we can neglect the inertia of rotor, and now new inertia will be the weight of our model. Currently we are discussing about the 200 kg and multiply by 0.279 multiply by 0.279 to make it square, right? So mr square, this will be our new inertia of the rotor. So how we can have each and every detail about this vehicle model, and we can use the inertia of the rotor, inertia of the cylinder having mass of the vehicle, that we need to put here. So I am directly writing the equation 200 into 0.279 into 0.279. So this way we can also write. So it will be our new J. Let's make it larger so it's visible. So this is the new inertia of the rotor instead of all old inertia. So this is what passive loading scheme is. And the second thing is we are not applying the constant load torque. So the application of constant load the devices are very less which having the constant load like compressor, but we are having the vehicle as a load. To have the vehicle as a load, we need to use this lookup table of this 200 kg vehicle model. So we will use this as a input load, and here we required the, because we have used the unit kilometer per hour. So this speed according to radius we need to convert in kilometer per hour. So let's do it. I am highlighting this so we can have speed in kilometer per hour. This is radian per meter, this is radian per second. We already converted in radian per meter. So I am using this gain block. And to convert revolution per meter, one revolution is 2 pi into r. R is radius 279 in our case. So what will be the output of this? It will be, here it will be meter, right? So it is, if radius is r, in one revolution it will complete 2 pi r meter. So meter per minute. So here we will get the meter per minute, or if we divide it by 60 we will have the meter per second, but let it be meter per minute. So we will add one more gain block to have kilometer per hour. So what we will do to convert from meter per minute to kilometer per hour? So we need to multiply by 60 to convert meter to kilometer, meter into hour, and from the meter to kilometer, 1000, 1 kilometer is equal to 1000 meter. So this is what we get, and I am using the one more display block here to set it, and this speed is in kilometer per hour. So now this is speed in radian per second, revolution per minute, and now we are having kilometer per hour, and this will become the input of our block, right? So you can do the two things, either you convert your speed that you have when you derive the lookup table to kilometer per hour to radian per second. So directly you can use the input from here, or you can do this also. So now our model is ready, and what passive loading scheme is say, when you consider the vehicle as a cylinder having mass of the vehicle and radius equal to the radius of the wheel. Remember, it's not only the radius of rim but radius of wheel. So you need to consider both rim plus height of the tire. So this is the actual model, and passive loading scheme say when you do this, we do not require further the model of the vehicle, and only this model will act and behave as a your motor is loaded with the 200 kg vehicle, and it will give the speed and all the characteristic like this. Now if we want to know with the 250 volt maximum voltage is there, what will be the maximum speed with this motor we can achieve for the vehicle model of 200 kg. Let's run the simulation, and how much time will it take? You can see 49.36 in speed in kilometer per hour. So this is what maximum speed that we will achieve when supply the full voltage 240 volt. Let's observe the response. see, when we see the response, because now inertia has increased and in the 10 seconds we are not achieving the final steady state speed, so we need to increase the time period. So I am increasing it to 100. Now you can see it is 95. So this is the what maximum speed that we can achieve. And let's see the response. Either we are getting steady state, yes, so here we are getting the steady state speed. We can have the response, and we can also see to achieve the 60 second it takes the around 14 or 13 second, 60 km/h speed. And so this is what maximum speed that can be achieved with this 5 HP motor for the vehicle model of 200 kg. We do not require the vehicle model anymore, it will act as a same. So this is what passive loading scheme say. It says change the inertia of the rotor, replacing by the inertia of the cylinder having mass equal to the vehicle and radius equal to the wheel of the vehicle, and add the lookup table as a load torque, and your model is ready to be performed and to be analyzed. So now we can do the different analysis on this, but before that, in next session we will validate how we can validate is the scheme and is our model is actually performing the same way as the vehicle model. So hope you got the idea how to build the model of the electric vehicle.